Hi, welcome to CreepGame Assignment 3.04. Here are the requirements. We want to create an AI system using a finite state machine or decision tree. This should be a reusable system so that our code can be easily modified in the future. We want to add a new AI player using the entity system, and we want the interface between the AI player and the AI logic system to be a component. We want to use A-star pathfinding. And the AI player must fetch the flag, then return to his goal to score, and then repeat. And the AI player must make effective use of sprinting. Then we have a tag system. To stop a flag carrier from scoring, you have to get close enough to him. And if he is tagged, then the flag he's carrying gets reset back to its original position. And if both players are carrying a flag when a tag occurs, then both flags are reset. Okay, quite a bit. Let's get started. Here's our solution. Let's run the program. Okay, so there's the AI player on his goal towards the flag. Notice he's not sprinting. I'm going to go grab, let's sprint a little bit here just to hurry it up. I'm going to go grab the blue flag and then wait for him to come get me. Actually, come tag me. Okay, so he's on his way towards me. And okay, now we both had the flag and I just got tagged and I no longer have the flag. If I pull back, you can see there I am without the flag. And the flag's in its position again. Go grab it one more time, and I'm going to come down here and watch. There I am with the flag. There's the post up there without a flag, and now we can see that the AI player is about to come. There he is sprinting back, and he's about to score. He's run out of sprint, and he gets the score, and I lose my flag. So we can see the tagging system works well. The flag reset system works well. We can see that the AI player is following his pathing from waypoint to waypoint. So let's take a look at some code. Actually, before we look at the code, let's take a look at a state machine that I've developed for the game. So there's two types of transitions in this state machine. There's these unlabeled ones, which occur immediately, and then there's these labeled ones, which can only occur if a particular condition is met. So we start here, we immediately transition to get path to flag. So right now our flag is the goal and we want to path to it from wherever it is we are. As soon as we create that path, we now move over to this other state. And get current waypoint really means from where I am, whatever the next waypoint is, I'm going to call that my current waypoint. And then I immediately move down to this box here. And this box, there's no way out of this box except if a condition is met that we reach the current waypoint. So basically the whole idea here is we stay in this state, moving closer and closer to our current waypoint. And finally, when we get to the current waypoint, we get out and we're either at our goal or we're still along the path to our goal. If we're still along the path, then we get the next one and we can continue this. And we keep doing this until we finally get to our goal. So the goal was our flag. And if we notice here, state B says, once we have the flag, let's sprint home to the score box. So in other words, if I finally get to my goal, which is getting the flag, I've now got it. Now my new goal is let's get home so I can score. And then it immediately transitions here, and then this whole thing happens over again until I finally get home and score. In which case, I make this 8 transitions as upon scoring, let's start it all over again. Now the only thing that can mess that up is if while I have the flag I get tagged, in which case we sort of hop out of this whole system here and start all over thanks to this global watching for tag states. Okay, so now that we have an idea of the state machine we wish to create, let's see some code here. Okay, so here is our state class. And you'll notice that there are 3 virtual functions, enter, exit, and execute. Now, enter and exit are basically set up and tear down for a class, and they have a default implementation of doing nothing. So if we don't need those, we don't have to code them up, it's already done for us. But this execute virtual function purposely has no implementation. We have to implement it to create a proper state. And then I've got some macros down here that make state creation a little bit easier. And basically they say that all you really need to do to make a state is, to make a new state, is to have a line like this in your header file. And then have a line like this in your code file. So let's take a look at an actual implementation of these states over here. Okay, so here's my my waypoint states header file, and you'll see that I'm using those macros, and I've created 5 states to match the 5 states I have over here. So we have the get path to flag state, which is this one, get current waypoint state, this one, move to current waypoint state, namely this one, get path to home state here, and then we have this global flag watcher state here. So using the macro system, you can see it's very simple to create new states. Now let's take a look at the code for these states. Remember, we have to implement the execute method for them. Okay, so here is the get path to flag state. Basically, we set up some variables that we're going to use. We use the machine has the enemy flag entity, which we're going to need access to. The flag mesh entity we're going to need access to, so we know where the enemy flag is. We get its position from there. We need access to the pathing component so that we can create a path for this entity, and we need access to the sprint component so we can turn sprinting on and off. So here's the actual code though for this particular path. Basically, we say let's turn sprinting off. Let's find the center of the flag mesh of the enemy. This is the enemy flag mesh. Let's find the center. So basically, we want to get a valid path from wherever I am now to the center of the flag. So that's my goal. And when I get there, I'm going to push this. Right now, I'm going to push this state, get path to home, so that when I get there, that'll be my next state. And now I want to take this transition and make the next state. Right now, I want to make it this get current waypoint, and I want to get rid of any global state if there is one. And we come down here to the next. Here's the execute for the get path to home state, this one here. So this one says when I've got the flag, okay, that's what I'm in here is when I've actually got the flag. So I want to turn sprinting on as soon as I get the flag. Now here I want to get the center of the home flag. So I want to make I want to find a valid path from where I am now to my home flag so I can score. When I get there, when I finally finish this, the state I want to happen next, so I'm going to push it, is this get path to flags. This will just restart everything. And right now I want to transition over to the get current waypoint, and I want to make my global state, because I've got the flag now, I'm vulnerable to being tagged, so I need to make this global state, this flag watcher state. Okay, so here we have the flag watcher state, and basically all it does is it asks the score zone thing if my entity has the flag, and this particular entity has the flag, and if it doesn't have the flag, it must have been tagged and the flag went home. So then it says basically clear the stack and change the state to this one here. Basically it says let's start over. Okay, and now here is the get current waypoint state. That's this one over here, and this is the one which needs to find the next state, the next waypoint that we want to get to. So basically here's the pathing, access to the pathing component of the entity, and we're saying get me the current valid node. What that means is figure out where I am right now, figure out where it is I'm supposed to go, and tell me which is my next path along the way. That's my current node. And if that current node exists, then move down here to the current way state point. If it doesn't exist, that means I must be there. So let's pop the state and do the next thing on there, which of course if we're going to the flag would be this, or if we're going home it would be this. And finally, we have this move to current waypoint state, and basically it says, um, let's move the entity and see how far he is from his goal. And if he's close enough, in other words, if this waypoint arrival distance has been made, then we'll assume he's actually there. And what we want to do then is want to get the next valid node and change our state to the current waypoint state. Okay, so that's all the states that we need. Now we need a state machine to execute on these states. And here's a state machine. And we'll see that the state machine knows about a current state and a global state. And it has an update. Now notice all this code is actually in the .h file. So it has an update routine, and the update routine basically says if there's a global state executed, if there's a current state executed. So every update we give the current state and the global state a chance to execute. So to change a state, we find out what the current state is and give it a chance to do a teardown. Then we make the new state the current state, and we give it a chance to do a setup. And pushing a state basically just says put it on the stack. Nothing that I'm currently doing needs a change. Just push this on the stack. And pop a state says get the top state off the stack and let's change that state. Let's make that our new state. And clear stack just gets rid of all the states that are in the stack, if any. So that's a generic state machine. You'll notice there's nothing about the game in there. This is a purely generic machine. So the machine that we actually use, though, is this capture the flag machine. This is the one that knows about the game, and you can see it's based on that state machine. And really, all it is you've got this setup thing where you pass in some variables, which are these variables here, and then these are all getters for those variables. So this is really just a wrapper around that machine with some access to variables to make coding easier. And if you look in the code file, you see this is just the setup that just sets all those variables. So let's see where the player actually gets created. So here's where we build the blue player, the AI player, and we add all the components to them. You'll notice here we have this, this is where we add the finite state machine. And down here is where we initialize or capture the flag machine. And we tell it the first state to go to, and we give it those variables that it needs to access more easily. And then we say hook up the component to this machine. We say here's the component for the finite state machine. Let's tell him that this is the actual AI machine to use. Now let's take a look at the .h file. You'll see that the finite state machine is an FSM component. And if we take a look at that, it's just a regular component. And notice in its update, it basically says just give the machine a chance to do its update. And then if you want to change a state, tell the machine to change a state. But I don't believe this is actually being used yet. So that's an overview of my AI system, which is basically a state machine with a bunch of states that are very easy to make, hopefully very easy to upgrade in the future. So that's my overview for the CreepGame Assignment 3.04. Thanks for watching. Goodbye.